So in this video, we're looking at the derivation of the formula for the sum or difference of indexed terms when we're using sigma notation. So the claim was that if we want to take the summation from I equal 1 to n of the sum or difference of indexed terms, and remember indexed terms just could be anything like I squared, I cubed, square root of I, any variable term indexed via the variable I, that if we want to take the summation of the sum or difference of the indexed variables, that we are okay to take the sum or difference of the summation of the indexed variable. So we can break it into the sum or difference of the individual summations. And really this is just going to utilize commutative associative properties of addition. So if you were to look at the derivation of it, you would simply start off saying, hey, I want to take the sum from I equal 1 to n of a sub I plus or minus, it won't matter, b sub I. And what would this equal? Well, we know we're starting with an index of 1, and then we'll increment it to a 2, dot, 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 and we'll keep incrementing out until we get to the upper bound of summation n. So the first term that we would get from this series would be the term a sub 1 plus b sub 1. And then it would be, sorry, a sub 1 plus or minus. I'm trying to do both at once. So plus or minus b sub 1. Stop making typos. Plus, then you would subscript them with the 2. So you'd get a sub 2 plus or minus the b sub 2 plus. And there's going to be n terms in this series, so you go all the way out through a sub n plus or minus the b sub n. And the idea is that you can regroup this. You can regroup it either at, you can regroup it as you can take the a sub 1s and add them together, a sub 1 plus a sub 2 plus dot, 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 all the way out through the a sub nth term, and then you can add to that, so the plus or minus, and then you group the b's, the b terms as well. So you do b sub 1 plus the b sub 2 plus dot, 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 plus the b sub n. So you break up the additions so that all of the a sub i's are grouped and all of the b sub i's are grouped. And then you're gonna have a plus or minus. So the idea is, I mean, if we're being a little bit careful here, you're gonna have a plus or minus, plus or minus, plus or minus. And if it happens to be, we could do it like this, plus or minus, put all the b terms together, and then you're gonna factor, if it's a minus, you can factor that minus out. So I guess we should be a little bit careful. You get, yeah, plus or minus b sub I, plus or minus b sub 2, plus or minus dot, 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 plus or minus b sub n, because there's a plus or minus c in front of all of the b sub i's. So you wind up with a sub 1 plus a sub 2 plus dot, 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 plus a sub n, and then this plus or minus can be factored out using the distributive property, which is going to leave behind, if it's all pluses being factored out, it's still going to be pluses on the inside. If it's minuses being factored out, you're still going to get just pluses on the inside. So you get plus b sub 2 plus dot, 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 plus all the way out through the b sub n. And then you want to recognize that each of these are can individually be represented with the summations from I equal 1 to n. This is the a sub i's plus or minus the summation from I equal 1 to n of all of the b sub i's. So we can break it into individual plus or minuses where we take the summation of the index terms individually.